In this video, I'm going to talk to you about the domain and range of relations. Before I go into too much detail about the domain and the range, I'm going to talk to you about the notation that we use to describe these two things. So I'm going to use some number lines and some notation over here to talk to you. So we use a closed circle when the number is included, and we use an open circle when the number is not included. Likewise, brackets go with that. So we use square brackets. So you can see I've done a square open and closed bracket. So that would, if it's included, if the number's included, we would use the square bracket. Or if it's not included, we would use the round bracket. So let's just do some examples. So I'm just going to draw a closed circle there and a closed circle here and a line between them. That means that this set of numbers, all these numbers in between these two, 2 and minus 3, are included within our set. So let's use this notation here to describe it. So I'm going to go with square brackets because they're closed circles, so the numbers are included. And this set goes from minus 3 all the way up to all the way up to 2. And it's included, so we use a square bracket. All right, let's go on to the second number line. So this time I'm going to use an open circle. So let's just draw an open circle here. So that means that's not included in our set. I'm going to go all the way up to the number 1 and I'm going to make that included. So I'm colouring in that circle. So when I use the bracket notation to describe this, because minus 2 is not included, so it begins at minus 2, I use a round bracket and I go all the way up to the number 1, but 1 is included, so I use a square bracket. And this is a sort of notation that we use to describe the domain and the range. We also use interval notation using greater than, less than, or equal signs. So I'm going to just talk to you about what that would look like within this. So we've already said it starts at minus 3, so x has to be greater than or equal to minus 3. So we go minus 3. Okay, so the x has to be greater, so that's where the open mouth is, and equal to minus 3, all the way up to less than, including, so we have to include the number 2. And this is another way that we use to describe the domain and the range. It's another use of notation. Again here, if we look down at this one, well, it begins at minus 2, but minus 2 is not included. So we just use that symbol there because there's no equal sign underneath. And it goes all the way up to 1. Well, 1 is included, so we have that equal sign there. So this says that x must be less than or equal to 1, but x must also be greater than minus 2. I'm going to use the number line now to change this interval notation. So I'm just going to change this slightly, and I'm going to use infinity, because infinity is often used as well. And when we use infinity, positive infinity or negative infinity, we don't include that as part of the interval. So it becomes a round bracket when we are writing it as interval notation. So just put that on there. So I'm going to go, let's just do an open circle at minus 1 and a continuous arrow. So that indicates it's going in the positive direction continuously that way. So when we write this down, well, we can see minus 1 is not included. So we use a round bracket. So it goes from minus 1 all the way up to positive infinity, and we use that closed bracket like that, as in round. So now that we've sorted the notation for the domain and the range, let's talk about what the domain is and what the range is. So we talk about the domain involving all those x values, that independent variable that work for a particular relational function. So for example, sometimes you could have a set of numbers or a graph. So you're interested in what x values work for that particular relational function. The range is to do with the y values. So we're only interested in what y values work for the particular relation that we're dealing with. Often on a graph, it's easy to see what values of y work for that function. So what we're going to do is we're going to look at some examples. I'm going to do 4 examples altogether. So look at this one. This is what we call discrete data. It's not continuous. If this was plotted on a graph, it would just be dots like that, not joined up. So when we're describing the range and the domain for this particular relation, we would put that as a set of values because there's no link between the x values. They are discrete. So I'm going to use a set. So the domain for A is, well, 1, 2, 3, and 4. So we're interested just in those numbers. Okay, so no relation. Now look at the range. The range, again, is just a set of numbers. 2, 5, 8, 11, and we do that as a set. 2, 5, 8, 11. Okay. Now, when we look at b, well, b is on a graph, and it's a continuous function because there's a line all the way around. It's a circle. If we have a look at the x values, well, let's have a look. -1 to 1 is what is within the domain of this function because we're only looking at the independent variables. -1 to 1, -1 is included and 1 is included. So I'm going to write that down. I'll just clear some space. So I'm going to use the interval notation for the domain. So we're going from -1 included all the way up to 1 included. So because it's included, we use those square brackets, -1, comma 1. Now look at the range of this circle function. Again, similar thing. Includes -1, goes from -1 up to 1, and it includes. So we would use it as the same notation, except instead of x, we're looking at the range, so we're looking at the y values. So it goes from -1 to 1, and because they're included, the range is -1 to 1. So let's look at some more examples. Look at this one here. We've got a graph, and we can see it's a parabola, it's a quadratic. Now, looking at the curve, it's got arrows to indicate it's continuous. It goes continuously to infinity and negative infinity. So what we say about the domain of this particular function is every single value of x in the real world in the real number system is involved. So we use the set R to describe its domain. So its domain would be just R. Okay, now if you've watched my sets videos, you'll know that R stands for all the real numbers. Now look at the range. The range begins at, or the y values begins at 0 at the origin, and it continues up to infinity. So when we describe the range of this particular function, we can use the bracket. So 0 is included, so we use a square bracket, 0 all the way up to positive infinity, which is a round curved bracket. Let's look at D. Now, looking at this, the line is a straight line graph, but there aren't any arrows like the above example. They finish using closed circles. So we know that 1 and 4 on the x and y are included, but it's not a continuous function, so it doesn't go to infinity and negative infinity. So if we're going to write that down in terms of the domain, we could write it as interval notation, or we could just write it using the brackets. We know that 1 is included, so we use a square bracket, 1 comma all the way up to 4, square bracket. Same with the range. The range is exactly the same. It goes from 1 to 4 and is included, so we have square brackets.